Okay, so decide which intermolecular forces act between the molecules of each compound. So I need to write the lowest structure, right?
Yes.
Carbon, hydrogen, chlorine. Okay, I have to decide.
Then you start asking, is the molecule symmetric?
So it's not symmetric, but it is tetrahedral.
Yes.
Mm-hmm.
So it's not symmetric. Does the molecule has a central atom with lone pairs?
No.
Does this molecule has any bond polar?
Let me see, because I'm not that smart to know that off the top of my head. Yes, between carbon and chlorine.
So therefore, this molecule is what?
It is a polar molecule.
If I have a polar molecule combined with another polar molecule, what type of interaction do I have?
Is polar? Is that dipole?
It's a dipole.
Okay.
If it was non-polar and non-polar, then it would be a dispersion.
So, even though this is not polar, just because this bond right, these two here are polar, that I'm okay.
Yes, make it polar. And I'm just following that chart that she gave you.
Oh, okay.
So makes it a polar.
So say you only had one chlorine, you didn't have the top one, and so you had two not polar bonds.
But still, you have a polar bond.
Okay, so even if you have just one.
Only one.
Okay, just like if you had just one lone pair.
Yes.
Okay. Dipole. Well, that probably will help me with those more.
Well, dipole and dispersion. Every time you have a dipole, you also have a dispersion.
Okay, so I was going to ask her about that, but I didn't get a chance before I had to come. So on these are what we did on the PowerPoint. She just walked us through these.
Mm-hmm.
And then they said, which of the above exhibit London dispersion forces? And it said all of them. Now, why is that when some of them, is it just because, does it kind of go in order? So if you're an H bond, then you have to have...
To be dispersion and dipole. Yes.
Okay. So all of them are going to be...
Yeah, if you're a hydrogen bond,
Is it
you're
that?
all three. If you're dipole, you have the
Yes.
dipole and dispersion.
And
If you're
dispersion.
dispersion, it's all dispersion. The idea there is that really in real life, I would say this molecule is polar, is a dipole. Done. I want to say it's a dispersion. But in theory, we
in
assume
theory,
they have all three.
so
Because
you would put like dispersion and dipole in this because it wants
Yeah.
all of them. So usually won't all of our compounds be dispersion then?
Usually chemist always says this is a dipole.
Mm.
Or if I have a hydrogen here, symmetric, so now it's a London, they won't say, oh, it's a hydrogen bond and a dipole and a dispersion. We just say it's a hydrogen bond. We just say the position, the interaction is higher, requires more energy to be braked.
Oh, we just know in our mind that that's what it is. Okay, so carbon tetrafluoride, so C with 4 fluorides. So that's symmetric, so it can't be polar.
If it is symmetric, it's non-polar. If I have non-polar interaction,
It's a dispersion.
dispersion.
Okay, and then chlorines. How would you know which one goes in the middle then? Because you don't have.
Well, I know hydrogen oxygen needs 2 electrons.
So those need to bond like that.
Yes.
So hydrogen is bonded to oxygen, so that's a hydrogen bonding.
Yes.
But it's also all three of them?
Yes.
Okay. Okay. And then so that is symmetric.
Mm-hmm.
So it's non-polar. So it's dispersion.
Yes. Good.
Yay. I'm so afraid I'm just gonna forget one of the little step things. Okay, silicone.
Yeah, it's some lots to have down.
So silicone tetrafluoride, that's going to be a tetrahedral, so it's going to, and it's going to be symmetric, so it's dispersion or London.
Dispersion or London.
It's nonpolar.
Good.
Sorry, I thought there was more people coming.
No, we're supposed to have 4. But then one canceled. He said, I figured it out by myself. And then and then she was good, and then Angela, they didn't show up.
Yeah, I think Angela, she just said that she finished it and everything, so. And oxygen, it's oxygen 6 valence electrons?
Yes.
Okay, so 6, 7, 8. So there's 12, 2, 4, 6, 8, 10. Do I need to go here?
Yes.
I never know, when do you know to make a double bond and when do you know to make a single, a lone pair?
Just depending, we want to make everybody happy. So if you have a double bond there, this will have 8 electrons. This will have 8 electrons, and this will have 2. So everybody's happy. So that one is the best configuration.
So yeah, because if I would have put it there, then oxygen wouldn't have been happy.
Yes.
Okay. So this is, so there's no lone pairs. It's not symmetric.
Not symmetric. No lone
Hydrogen
pairs.
isn't bonded to any of those things. So I have to check is it intermolecular force? Is that what it's called?
Yes. So you know that this is trigonal planar because you have that guy.
And no lone pairs.
No lone pairs, and then I see, is this bond polar or is this bond polar?
Okay, so carbon 15.5. Okay, so the one carbon to hydrogen isn't, and then but carbon to oxygen is.
Therefore,
So it's polar.
what type of interaction?
So if it's polar, then it's dipole.
Dipole.
I have to like envision that chart. So it's dipole. Okay. But that also means that it's
Dispersion.
dispersion. Okay.